So as mentioned earlier, today we are supposed to be going with this new topic called data transmission protocols. In the last class, when we ran the netstat command in our terminal, we had the first column here giving me some protocol names, TCP or UDP. So let's talk about those protocols today. What is TCP and what is UDP? So both TCP and UDP, Transmission Control Protocol and User Datagram Protocol, are protocols for data transmission across networks. So when one system wants to communicate with the other system, when it wants to send data, it will either send it using the TCP protocol or the UDP protocol. And each of these protocols has its own important characteristics. Firstly, when we talk about TCP protocol, this is a connection-oriented protocol. Now, what I mean by connection orientation is it has something called TCP flags, which give you a proper information on what is happening regarding the connection. So if I show this with a diagram, if I go back to my browser here, in my browser, I can draw this out. Let's assume there are two devices here, device 1 and device 2. And when they want to communicate with the TCP protocol, let's say there are two ports here in a listening state. Here's a port in listening, and here's another port in a listening state. Now, when these ports want to communicate with each other using the TCP protocol, device 1 will always send first something called a SYN flag, SYN. This SYN flag is usually used to initiate a connection. SYN stands for synchronize. So device 1 says, hi, I want to initiate my communication with you or synchronize our devices with each other so that we can transmit data. For that SYN flag, your receiver or device 2 now, so let's say this is device 1 here, and this is device 2 here. So now in response to that SYN flag, your device 2 now sends back something called SYN-ACK, SYN hyphen ACK. SYN-ACK is like the acknowledgement for your SYN flag. So it says, hi, I acknowledge that I've received your SYN flag and this is my confirmation or my reciprocation for it. And for that SYN-ACK, your device 1 sends a final ACK. Again, another ACK telling him that, hi, I've received your SYN-ACK and this is my confirmation or my acknowledgement for it. So whenever you talk about TCP protocol, these flags are always used to initiate a connection. So after the SYN-ACK and ACK, after this is performed, then the ports change from listening to established. So now the ports are in an established state where they can start transmitting data to each other. So this is established and this is also established port. Okay. And again, this collectively, this three flag processes collectively is called as TCP, three-way handshake. Okay. So when two devices want to communicate with each other, let's say in your network or when you're connecting to google.com as well, first things first, your device sends a SYN flag to Google. In return, Google sends you a SYN-ACK and then you send an ACK. After the TCP three-way handshake is performed and the connection is established, now you send data packets from your system to Google server. So these data packets now start traveling from one system to the other. And these data packets also now have some important properties to it in TCP protocol. First important property is their sequencing. So each packet has a sequence number, packet 1, packet 2, packet 3, packet 4, packet 5, packet 6. So there's sequencing where each packet is given a sequence number and the packets are sent in the exact same sequential order. So first packet 1 is sent. So from device 1 to device 2, packet 1 is sent. And for that packet 1, your device 2 sends an acknowledgement as well, a confirmation saying, hi, I've received packet 1. Now you can send me the next packet, packet 2. Okay, so it sends the next sequence number as well. Then packet 2 is sent. And for that packet 2, again, there's an acknowledgement as well. Saying, hi, I received packet 2. You can send me the next packet. Now let's say if packet 3 gets sent and due to some issue, let's say it gets dropped, it doesn't get sent to the target system. Then your device 2 will wait for a certain duration and it sends a message back saying, hi, I have not received packet 3. I want you to resend it again. And then packet 3 gets retransmitted. So these are all the features of TCP protocol. Error checking, various sequencing, and again, acknowledgement for each packet received, messages for packets not received, and retransmission of lost packets. All these features make TCP a very reliable protocol. So when you want to send data without any data loss, then TCP is the preferred protocol. But with all these features, TCP becomes a very heavy protocol. And since it's a heavy protocol, data transmission speeds are a bit low. Okay, so it doesn't transmit data very quickly. It's a bit slow on the transmission speed side. But even though this transmission speed is low, it sends reliable data. Okay, it's a very reliable protocol which does not miss out any data sent from one device to the other device. Okay, so it might buffer a bit, it might be a bit slow, but you see the entire data. So when you visit google.com, you search for something, you get the entire result there. It might be a bit slow to load the results, but you get the entire list of results. When you watch a YouTube video, it might buffer a bit to get the data to you, but you can watch the entire YouTube video as long as the connection is established. On the other hand, now you have something else called UDP protocol. Now in UDP, there are none of these features, guys. UDP is a very simple and a lightweight protocol. So let's say there's device 1 here, there's device 2 here. And let's say there are two ports open in a listening state. Now, when one device wants to send packets to the other device on UDP protocol, it just sends. So whichever whichever device requests data, it sends a request here. Oh, sorry, my bad. This is yeah. So this is the device 2. Let's say this is device 1 here, and device 2. And if device 2 wants data, it sends a request for that data. And with that request, device 1 knows, okay, the device is active, and it just starts sending the packets instantly. There's no sequencing, there is no error checking, nothing at all. All it needs to know if the device is active or not. So once it gets the request, it starts sending the data as a response. Okay. And all of this happens very instantly without any delay. Okay. So UDP protocol is a much more lightweight, simpler protocol which sends data in the first come, first serve basis. Okay. There's no sequencing. And even if any packet is lost, let's say packet 1 got sent, 2 got sent, but this third packet got dropped, it doesn't retransmit that third packet. It is lost forever. Okay. So there's no retransmission, there is no sequencing, there is no error checking, nothing. It is just serving packets on a first come, first serve basis. It's a very lightweight protocol. Okay. And thereby it makes it a very simple and a fast protocol compared to TCP. TCP data transmission speeds are a bit slow. UDP, the data transmission is the best. It's fastest, I would say. So when I'm communicating here right now, you're able to hear me there instantly. That is happening with the help of UDP connections. Okay. So for instant communications or live streaming connections or video calls or whatnot. So audio, video calls, IP, voice IP calls, etc. For instant communications, you always go for UDP protocol. Okay. For again, as mentioned, for reliable connections, for no data loss, you go for TCP protocol. Okay. So when you talk about UDP, when I'm speaking something, if the network is bad, you lose my voice in it. Now you don't get that voice again later retransmit. So once it's lost forever. Okay, so that's the example of a UDP protocol based. Is that clear? Charles and Vamsi, the difference between TCP and UDP protocol. Any questions, any doubts? Charles, any questions? Are you there? My mic, okay. Something's wrong with your mic. Oh, I muted it. I didn't know I muted it. I didn't mute anyone though. I think you can unmute now, Charles. But I didn't mute that. I think the institute muted it or something. Oh, okay. UDP, user datagram protocol. Okay, if you take the example of WhatsApp itself, Charles, I would say your WhatsApp's text messages are TCP protocol. So when I send some text to you, you see that entire text. There might be a bit delay, there might be a bit lag in that text. Once I send it here, you might receive it after 1 or 2 seconds there on your device. But on WhatsApp, the same voice call happens on UDP. As soon as I initiate a video call to you, whatever I speak here gets heard by you there. Okay. So much faster communication of UDP is like your gaming or live streaming or your Discord calls or whatnot. So wherever there's an instant communications, a live feed that involves UDP protocol, text messages, visiting websites, watching videos on YouTube, all of these are examples of TCP protocol. Okay. So instantaneous communications or short-term communications are for UDP. Okay. Or reliable communications, or I mean data where you don't want any data loss to happen, that is TCP. That's the main difference. Right. Now, moving forward, let's talk about a few other properties of the TCP protocol and UDP protocol. So, as mentioned, a TCP three-way handshake is performed first to establish a connection before data transmission, and every packet is given a sequence number, and the data is transmitted in that same specific order. For every packet that is sent, the receiver sends an acknowledgement back. Okay, and in that acknowledgement, you have the sequence number of the next packet to be received as well. And if the sender doesn't receive an acknowledgement, he gets to know that the packet is lost somewhere and he retransmits the previous packet again. So protocols like HTTP, HTTPS, FTP, all of these use TCP in their core level. On the other hand, when you talk about UDP, it is a connectionless protocol. Connectionless in the sense it doesn't have those TCP three-way handshakes or anything, meaning there is no prior connection set up between the sender and the receiver. UDP does not expect acknowledgements in return. So therefore, sender has no way to know if the packets are successfully delivered or if they are lost in transit. And if they are lost as well, it doesn't retransmit them again. Okay. So UDP is designed for applications where occasional packet loss is acceptable, but there's a need for faster data transmission, okay, such as real-time streaming, video conferencing, online gaming. All of these examples use UDP. Okay. So protocols like DNS, DHCP, voice over IP, TFTP, all of these use UDP in the core level. Okay. Now, when you talk about TCP, guys, there's a few important topics to know called TCP flags. So, as mentioned, there is something called SYN flag, ACK flag. But other than that, there's other flags also. Let's talk about those now. So, coming back to my diagram here. So, as these are protocols, already established protocols, I would say, Charles, again, which you cannot change in any way. The rules for them have already been set and they work according to their rules and regulations, okay, both TCP and UDP. And they're used in every single device present in the whole world. Again, they're pre-installed services, okay, globally known services. Okay. So now when you talk about TCP again, as mentioned, there's a few other flags also. Now, when one device wants to initiate a communication with the other device, it always sends something called a SYN flag. For that SYN flag now, if the system wants to accept the connection, in return, it sends something called SYN ACK, SYN ACK. It's an acknowledgement for the SYN flag. But if the other system doesn't want to accept it, so let's say the other system's port is closed or if it's blocked by a firewall or something, and if it wants to reject that communication, then in return, it sends something called reset RST. So RST is sent when the other system doesn't want to reciprocate the connection. So that's a new flag. Okay. RST stands for reset, to reject the communication before establishment. Okay. Now let's assume the other system did send us an ACK in return. For that SYN ACK, my system sends an ACK again, and that establishes the TCP three-way handshake. Okay. Now after the ACK is sent, after the ACK is sent, there is data transmission that occurs between both the devices. And after the data transmission, now if you want to terminate the connection, there's another flag called FIN flag. So after the data transmission is done, then one of the devices initiates something called FIN flag, FIN. FIN is to terminate the connection after successful data transmission. Okay. So once the data transmission is done, and when you want to kill the connection after that, you send the FIN, which stands for finish. Okay. And again, so these are four important flags: SYN flag to initiate a connection, ACK flag to acknowledge a connection, reset to reject the communication before establishment, and FIN to terminate the connection after establishment. And there are two other flags also: push and urge. Push is to remove all the packets out of the buffer. So whatever packets are being sent, if you want to remove all of these packets and wait for the next packet, then you assign the push flag. If not, if you want to prioritize only one certain packet, so let's say you want to, again, these have the packet sequence numbers here: 1, 2, 3, 4, 5. Now, in these entire set of packets, if the protocol deems any certain packet to be having a higher priority, then it assigns the urge flag to it. So this packet is given the urge flag. In such a scenario, when it is assigned urge, it means that packet is urgent and it needs to be sent before the other packets. These are not used by us anyhow. So these are just defined by the protocol itself to prioritize a certain packet or to remove all the packets from the buffer. Okay. So these are the 6 important TCP flags. Send to initiate or establish a new connection. Act to acknowledge or confirm the previous flag. Urgent to urgent or prioritize a certain packet. Push to remove all the packets to wait, without waiting for additional data to arrive. Reset to reject the communication before establishment. And fin to terminate the connection after establishment. Okay. And the reason I'm explaining you all this is because in the upcoming sessions, when we talk about Nmap, it works on the basis of these TCP flags itself. So Nmap is an application called Network Mapper to perform network and port scanning on foreign systems and figure out what ports are open on those devices. And that happens on the basis of these TCP flags itself. Okay. Let me explain how this works logically today. So let's assume there are 2 devices here again. Okay, so let's assume this is my Kali system, which has the Nmap pre-installed in it. And here we have the victim system on which we want to perform the scan. Now, in such a scenario, your Kali system uses one of its ports for Nmap. And on the foreign system, you have multiple ports which you want to scan right now over here. Okay. Now, what Nmap basically does is it sends a flood of SYN flags. So from its port, now it starts sending SYN flags on all the other important ports on the target system. Okay. So basically, it sends a list of SYN flags on all these ports. Now, for those SYN flags, according to the TCP protocol, whenever a port is open, that in return needs to send a SYN ACK back. So let's say these 2 ports are open, they in return will always send something called SYN ACK, SYN ACK. And whenever a port is closed, what does that port do? That in return sends a reset flag back. So these ports are closed, let's say. No worries, I have the diagram here as well, as you can notice, Charles. So again, as mentioned, when your computer is trying to scan a server for what ports are open on it, it always sends a list of SYN flags on it, okay, on all the important ports. Now, whichever port is open, that port in return sends a SYN ACK back. So these are all the ports on the system which are receiving the SYN flag from your Kali system. And whichever port is returned, open, in return sends a SYN ACK here. So that SYN ACK indicates that that certain port is actually active and running some service on it. And whichever port is closed, so if so-and-so ports are closed, they in return send a reset flag back. So from that distinguishing factor, your Nmap gets to know which ports are open and which ports are closed. So if it receives a SYN ACK, it knows the port is open. And if it receives a reset, it knows the port is blocked or closed. Okay, so that is basically scanning a target system for its own ports. Okay. So we'll talk about this a bit more in detail practically in the next session anyhow. But for now, this is what Nmap does. We'll be using Nmap a lot in the upcoming sessions where there's a lot of scan types. Okay, and again, it's completely terminal based, so we'll be working on all these commands. And there's a lot of options as well. We'll talk about all that in the next session anyhow. Okay. But yeah, for today, this is about it. Understand what TCP and UDP is and how you perform. What is Nmap used for and how does it perform its scan using the TCP flags? Is that clear, Charles? Right. So yeah, that's that. Nothing further for our session today. I think I've already shared this notes to all of you. You'll be getting the recording. Sure. To give you a date, Charles, I think we can conclude our sessions by 28th, I suppose. What do you think? Yeah. Don't. I'll try to do one thing. If possible, we'll try to take an extra session on this Saturday or so. Maybe I can still try to come. But not sure if all the other students will agree to it. So I'll confirm it with the other students as well, Charles. I'm not guaranteeing that, but if they are available also, we can take a session extra on 22nd. So that should help us out. Sure. We'll think about it accordingly. If that works well and good, if not, if for those few days, 1 or 2 days, you might have to depend on the recordings. Okay. Sure. So yeah, we'll work it out. No worries, Charles. Sure. That's that. Nothing further for our session. Let's exit the class and connect back tomorrow. Not tomorrow, so tomorrow's Saturday again. So we'll be connecting back on Monday again for the next session. Sure. Bye bye.